Okay, so over here we have the program that runs the weather station. First, we include the serial communications library, and we include these two libraries. The first one allows me to control the 7-segment display, and the second one allows me to communicate with the HTU1D sensor. And then over here I'm creating an instance of the object. And then over here we have the start hour and the start minute, where we define what time the program is uploaded, and Arduino will start keeping the time from there. Over here we set the initial threshold to 53, we set the update speed to 8, we start switches with 0, we set the initial delay speed to 1.3 seconds, we set the initial off time to 6.5 seconds, we set these two variables to 0, and then we just initialize all these ints, and we set the initial motion to 3. And also we say that the current hour and current minute is the start hour and the start minute, which we defined up here. Also, we say the previous minute is the start minute. We'll get more into this when we go into the clock function. Over here we set print temperature to true, so it starts off by printing temperature. We set save power is not, we actually don't save power, we put power save mode to false. We enable off false, and we create two strings, temperature and humidity. Also, we initialized LCD, or not the LCD, a 7-segment display to pins 12, 11, and 10, and then we say there's only one of them. And over here we set A0 to an output, which is how we control the photocell. We delay a bit, and we remove it from shutdown mode because it's in shutdown mode from the beginning. We set the brightness to 1 and clear the display. And we take the initial temperature and humidity readings, and we read the light. And we set the low val, high val, and first val to light, which we'll get more into later. And also using the light, we set the motion because during noon, the motion's going to be higher than at night. Or, yeah, but we can change that later. Alright, so now we'll get into these three functions, temp, humidity, and read light. So over here to read temperature, you read temperature 3 times to get an accurate reading. And if the temperature is above 99 degrees, it's probably wrong. So you take one more reading, and you convert it to Celsius. You convert from Celsius to Fahrenheit by just multiplying by 1.8 and adding 32. And then you just constrain it to 99.99 because that's the max it can display. And then you convert it to an integer n, multiply it to 1 by 100, so that all the numbers fall into the right place on the display, and you just return it. You do the same thing for humidity, except you just read the humidity. And over here you read the light, so first you write A0 high, and you read the light value, and you turn it back low, and you return the light value. So this saves power, because then you don't have to worry about wasting power on the photocell when you're not actually reading light. Okay, so now we'll just go into the program. So you start off by using this function in time, and this doesn't do anything, it's just sort of updating the time, because if we go down to the in time function right here, first what you do is you have the parameters, the lower hour, the lower minute, the higher hour, and the higher minute. And you calculate the hours since start. This actually isn't necessary, I just kept it in there for if I needed it in the future. But then you calculate the minutes since start by taking the milliseconds and dividing by 60,000, which is, these are 60,000 milliseconds in a minute. Then you say the current minute is the minute since starts, mod 60, plus the start minute, and all of that mod 60. And then also if the previous minute is 59 and the current minute is 0, that means the hour has gone up by 1. So you need to say the current hour is up by 1. And you do mod 24, so it's in 24-hour time. And you say the previous minute is the current minute, so you update this part again. And you say this part is for checking if it's inside the time. So you say is for each hour inside the range. You add 1 and you do mod 24 to do that. You see if the current hour is equal to I, and if it is, then you check if the current minute is greater than the lower minute, and the current hour is greater than the lower hour. So what this does is it checks is the current hour greater than the lower hour, because that means that you probably are in the time. And if the current hour is equal to the lower hour, you can still resort to this. So if the current minute is greater or equal to the lower minute, then this works as well. And then over here you do the same thing but with the higher minute. So if the current minute is lower or equal to the higher minute, then you're in the time range specified here. Or if the current hour is lower than the higher hour, then you're still in the time range over here. So return true. And if all of this doesn't work, then you just return false. So that's what this is doing. And this is just updating the time as right here. Because to be able to accurately predict the hour, you you have to update this at least once every minute. So this doesn't do anything right here. It's just sort of there to update the time. Because if you go back up here, you can see that current hour and current min are global variables. Suddenly read light, and then if the lowest value, if the current light is lower than the lowest value, then the lowest value so far is light. And if the current light is greater than the highest value, then the highest value so far is the light. And over here you have if the switches is greater than the update speed, then enable off is false. Well, you set it to false. And then if the lower value is greater than the first value minus the motion threshold, which we defined up here, and the highest value is less than the first value plus the motion value defined up here, that means that nothing has moved in that time. So that means that you can enable off. And else, you just reset everything. And over here, you redefine the motion values to suit the daytime. Over here, all this code does the exact same thing just for different times. So it accesses current hour and current minute, which is global variables, and it changes the threshold throughout the day depending on what time of day it is, basically. So at noon, the threshold will be 410, but at night, it's just going to be 43. So it just sort of provides a way so that the threshold is always at the right value. And you reset switches and you retake temperature and humidity. And also, all of this will occur every 8 switches. So after, it will display the temperature and humidity 8 times, and then it'll do this. So that amounts to, I believe, about 2 minutes or so. And if the light is less than threshold, that means the lights inside the house aren't on. So you shut it down, and here you just update the time again, and you update the time again here, and you do switches plus plus. You just add 1 to switches. And also, if the light is not less than the threshold, then you check if it's in time. This is the only part where the time actually matters, this function right here. Because this is the only time we're actually using the true false value outputted by this. So if it's in between 11:45 or in the 11:45 p.m. or 5:30 a.m., then shut it down and delay for 58 seconds, which is just less than a minute. And you update the values again. And then you update switches, but only so much up to 7. So then the next time it displays temperature, it'll go straight to this code right here. Okay, and if the light is greater than threshold and it's not in this off time, then you go over here. If enable off is true, which over here we say when there's no motion, then what you do is you delay half a second 10 times, so that's 5 seconds, and each time you read the light and you update the time. So basically what you do here is you're just checking for motion rapidly right here. And this may seem like it's using more power because you're constantly applying more power to the photocell, but over here we shut down the LED, so it's actually using less power. And after every 5 seconds, you're going to set it to false, and if over here there was no motion, you set it back to true, so it's going to go back out and then go back right into this part right here. And if there was motion, then you reset everything, and then you redefine the motion values based on the light. And then over here, if there was motion, so first of all you check if the light is greater than threshold, and it's in the time that it's allowed to display temperature, and there is motion, then you start displaying things. So you don't shut it down, so you set it to false, and you map the brightness from 1 to 3. 3 is the max and 1 is the least. Using these values, the threshold plus 75 through 875. So it's an adaptive display. So if the light is brighter, then it makes the LED brighter. And also, if power save mode is true, which will only happen when the battery is low, then the brightness is always set to 1 and the delay speed is low and the off speed is high. Most of the time you're not going to do that, so the delay speed will be 1.3 seconds and the off time will be 6.5 seconds. And you set the intensity to the brightness defined up here. And then and then if print temperature is true, so if you're going to print temperature, you just print temperature and you print the F on the first character, so like 72.5 F, so you can see it easily there. Then you delay, so it's gonna stay on. It's gonna show the temperature, the delay speed, which is 1.3 seconds most of the time, and you're gonna update the time, and you're gonna shut it down. And then what this is basically doing, it's just delaying for the off time, but while it's doing that, it's also just reading the light. So that's all that's doing. And then you update the time again. And then what you do over here is you display the humidity. It's the exact same process, but you're just displaying humidity and you're displaying an H. And then if the battery percent is less than 20, which you calculate by find voltage, which is a function defined down here, where you just read the analog voltage over here 15 times, and you do a series of calculations to find out the percentage, and you just find the average of that and you return that. So that means if the percentage of the battery is less than 20%, then power save mode is activated, and after you display the humidity, you're going to print the battery voltage or percent. It'll show that for 1.5 seconds and you'll update the time again. And if it's not, if the battery's not less than 20, then power save mode is false. And you shut this down again, and then you delay 10 seconds just to let this shut down, and you read light again, and you update the high value and low values. And over here you do the same thing, you just delay it for 6.5 seconds, but you just divide it into 4 sections where you can read the light 4 times in between. And you update the time again, and you have switches. So that's all that does right now, and then in the future what I'm going to have to do is update the clock so that it doesn't depend on millis, which you can see right here. Because millis overflows after 50 days, which means this whole thing will overflow after 50 days, making it inaccurate. So if I decide to make my battery life higher, this isn't gonna work. So I'll just have to convert this into a way that I can keep this from overflowing for a longer time. Thanks for watching. Bye.